Okay. Now things with 2 divided by x or -1 divided by x, these actually show up a lot more than you would think. Okay. Uh, so let's try this. Okay. So remember, once it's in standard form right now, this p of x is going to give you, it's e to the integral of this 2 divided by x. This is your p of x right here. Okay. So the integrating factor is going to be mu of x, which is going to be e to the integral of 2 divided by x dx. Okay. One of the mistakes I've seen people make in the past is they ignore the 2. No, that 2 is actually really important. Okay. So what's going to happen to this 2 is, by the laws of logarithms, I'm going to be able to pull this 2 into the exponent, so this guy becomes x squared. Guys, so if there's a number multiplied by this 1 over x, it becomes really important because it ends up becoming the exponent. Okay. Okay, so now watch what happens when I multiply both sides of the problems by x squared. Okay, so when you multiply x squared by 2 over x, you're just gonna be left with 2x. And the thing that I want y'all to notice is, what's the derivative of x squared? The derivative of x squared is 2x. Okay, so again, this is the product rule, right? And so again,
Wait, can you work out how you did that? I'm not sure I'm understanding how you're getting the first prime.
this one.
Yeah,
Oh, how do we run from here to here?
yes.
Sure. We'll put this on a different page. Think of it backwards. Okay. So if I was going to take the derivative of x squared times y, okay, this is going to look a little strange, but think about it like this. This would turn out f prime would be 2x times y plus x squared times dy over dx, like that. And you just flip the order of this around, and so that turns into okay. So it's literally the product rule, right? But right, what I'm doing on this is I'm actually doing the product rule. Say that if I take the derivative of x squared, right, so that's f prime g plus f g prime, and then I swap the order. But it's literally, you have to imagine yourself undoing the product rule.
And the best way to like know this is just to be familiar with the derivatives.
Look, this is gonna happen on all of these problems. Whenever you multiply by the integrating factor, it essentially undoes the product rule, and you're always gonna be left with just the integrating factor multiplied by y. Okay, that's the idea of all of these, multiplying by the integrating factor. Because once you've multiplied by the integrating factor, notice the integrating factor that you multiplied by was x squared. Okay, what is the derivative of x squared? The derivative of x squared is 2x. And so you'll always end up with your integrating factor right here, and then you'll have the derivative of the integrating factor here. Okay, and that's how we get to just this is undoing the product rule. But just realize that here, let me remove the bottom stuff. After multiplying by the integrating factor,
I see now, I think.
okay, but all right. The main thing about it is just you're always going to think about undoing the product rule. Okay. Now, once you've undone the product rule, you're going to integrate both sides. Okay. And this side is just going to become the integrating factor multiplied by y, which is going to turn into 3. Now, x squared divided by 2 plus c. Okay. Now, on a lot of these problems, I mean, the left-hand side of the problem is always going to become just your integrating factor multiplied by y, because that's the entire idea of undoing the product rule. But on the right-hand side of this problem, you still have to integrate this. So that's why on some of these problems, you might run into, you may have to do integration by parts or use substitution, different things like that to actually solve the right-hand side. But the left-hand side is always going to be the integrating factor multiplied by y. That's the idea of multiplying by the integrating factor. Okay. And the very last step of the problem is now to divide by that integrating factor. And that is the final answer.